We tend to imagine Belize's history starting with the inland Maya, temple builders, astronomers, and maize farmers deep in the jungle. But what if the story began somewhere else entirely, on the coast? What if the first people to walk Belize's shores weren't Maya at all, but distant travelers from regions few expected? For the first time, ancient DNA from human remains buried near Belize's barrier reef is challenging long-held beliefs about who settled these lands first. Before we start, I'm on a road to get 1,000 subscribers as a small channel. If you want to help me, please subscribe. Let's go back to where the land meets the sea. Belize's coastline is a natural gateway, fringed with barrier reefs, dotted with mangroves, and lined with river mouths that stretch far into the interior. Today, it feels like a lush edge of the Maya world, but thousands of years ago, this coast may have played a very different role. Traditionally, scholars believed that early humans in Belize came from inland roots, settling in forested river valleys to grow maize and build villages. The coastal regions were thought to be secondary, developed later as inland populations expanded outward. But this assumption never fully explained early shell middens, saltworks, or the presence of human burials in seaside caves that predated known Maya communities. Could it be that the coast was not just a peripheral zone, but an original point of entry? With new advances in genetic sequencing and a closer look at overlooked coastal sites, researchers are beginning to see the Belizean shoreline as a center of innovation, not just adaptation. Recovering ancient DNA from Belize isn't easy. The tropical climate speeds up the decay of organic material, especially in acidic soils and humid coastal zones. Bones break down fast, and DNA, already fragile, becomes fragmented or lost altogether. For years, these conditions made it nearly impossible to study human genetics in the region, but recent breakthroughs changed the game. Scientists now use a method called hybridization capture, which acts like molecular fishing. They design specific probes that latch onto ancient DNA fragments, especially from dense bones like teeth or the petrous part of the skull. Once extracted, these fragments are compared at key markers called SNPs, points in the genome where variation is common between populations. By mapping these variations, researchers can determine where individuals fit on the broader genetic landscape, and for the shores of Belize, this meant, for the first time, a chance to match ancient coastal remains to their closest ancestral relatives across the Americas. Archaeologists have long known that Belize's coastline held clues to early human activity. Sites like the shell middens of Chetumal Bay, the submerged saltworks of Paynes Creek, and the cave burials near Placencia all point to a vibrant, sea-connected world. These weren't the monumental cities of the inland Maya, but they showed signs of innovation, complex fish traps, canoe routes, and even preserved wooden tools in anaerobic peat. Some of the oldest radiocarbon dates from these sites stretch back over 5,000 years, predating the earliest inland agricultural villages. Yet the cultural signatures often didn't match those of the later Maya. The tools were simpler, the diets more marine-focused, and the burial customs less formalized. Until recently, this was assumed to reflect an early Maya coastal adaptation. But the DNA now tells a different story. Some of these people may not have been Maya at all, but an earlier wave of maritime foragers who settled the coast long before farmers arrived. When scientists sequenced DNA from ancient coastal individuals in Belize, they expected to find clear signs of early Maya ancestry, genetic markers linking them to the broader Mesoamerican population. But what they found was far more complex. Some individuals from pre-Maya coastal sites clustered genetically with ancient populations from lowland South America, including groups tied to the Amazon and Pacific coasts. These lineages were distinct from the later Maya and showed no strong connection to the highland Mesoamerican ancestry that dominates inland Belize. Other samples revealed a blend, genetic signatures of Maya-like ancestry but mixed with these earlier coastal genes. It was the first real evidence that at least some of the early coastal populations came from entirely different migration waves, possibly arriving from the south via canoe routes along the Caribbean. These findings challenged the long-standing belief that Maya culture simply radiated outward to the coast. Instead, the coast may have been a genetic and cultural frontier from the start. The DNA revealed not one, but two major waves of early coastal settlement in Belize. The first wave, dating to roughly 7,000 to 5,000 years ago, consisted of maritime foragers with genetic links to South America. particularly the Amazon basin and Pacific lowlands. These early people were likely skilled canoe navigators, following reef systems and coastal currents northward. They settled along Belize's shores, relying on fish, shellfish, and coastal plants with little to no farming. Then, around 3,500 to 2,000 years ago, a second wave appeared, this time carrying Proto-Maya ancestry. These later arrivals brought with them maize agriculture, pottery traditions, and village-based living. Unlike the first wave, they had strong ties to highland Mesoamerican populations. The meeting of these two groups appears in the DNA as a layered ancestry. Some individuals show admixture between the foragers and the farmers. Instead of a clean replacement, the genetics suggest interaction, cohabitation, and perhaps even shared knowledge along the Belizean coast. The genetic record shows a surprising pattern. Despite living side by side for centuries, the early foragers and incoming farmers didn't completely merge. Some coastal individuals carry 20 to 30% of their ancestry from the earlier maritime population, while others appear almost entirely Maya. This suggests limited mixing, enough to leave a trace but not enough to fully homogenize the population. Whether due to social boundaries, different languages, or distinct ways of life, these groups seem to have maintained some degree of separation. Yet, the presence of blended ancestry hints at cooperation, shared spaces, and possibly intermarriage at community edges. To understand the deeper roots of these coastal populations, scientists analyzed mitochondrial DNA passed through mothers and Y chromosome DNA passed from fathers. The earlier forager individuals carried mtDNA haplogroups like A, 2 and B2, markers often linked to ancient South American populations. Later, coastal individuals began to show mtDNA lineages like C1 and D1, more commonly found in Mesoamerican farming communities. On the paternal side, the earliest males had a mix of lineages, while later ones increasingly carried Q1A3A1, a Y chromosome type strongly associated with Maya ancestry. These shifts mark a genetic transition, one that mirrors the larger story of cultural blending along Belize's shores. These findings are reshaping how we understand the origins of Maya civilization. For a long time, the Maya were thought to have emerged inland, developing cities, temples, and writing systems deep in the forest, then gradually expanding outward. But the ancient DNA from Belize's coast tells a different story. Long before the rise of Maya kingdoms, the coastline was already home to people, some with roots in distant parts of the Americas. Their tools, diets, and genes show a maritime world rich in movement and exchange. And when the inland Proto-Maya began expanding, they didn't just bring culture to the coast, they found people already living there. The blending of these groups may have shaped early Maya society in ways we haven't fully appreciated. Maritime knowledge, shell-based economies, and even the use of salt may have flowed inland from the coast. In this view, the Maya didn't just spread outward, they also absorbed and transformed what they found along the water's edge. Despite these breakthroughs, many questions remain unanswered. Ancient DNA has only been recovered from a handful of coastal sites, and many others, especially those submerged or eroded, have yet to be explored. Could there be even older remains beneath the mangroves or under the sea, waiting to reveal new migration waves? Researchers are also eager to study trade networks, tool styles, and linguistic traces that might show how coastal and inland communities interacted. Were there regular canoe routes between southern Belize and Honduras? Did salt or seafood become early trade currencies? The genetic map has opened the door. Now archaeology must help complete the picture. The shores of Belize hold more than white sands and coral reefs. They hold the memory of forgotten peoples. Ancient DNA reveals that the first to walk these beaches weren't necessarily Maya, but early seafarers with roots in distant lands. Their legacy, though mostly buried, lives on in the genetic threads woven into coastal communities. As we uncover more of their story, we may come to see the Maya not as a beginning, but as a convergence. What do you think these early coastal people passed on? Let me know in the comments, check out the Patreon, and don't forget to like and subscribe for more.